The definition of irrational number is a number that cannot be written as a fraction and is a non-repeating and non-ending decimal. Let's see some examples. Some examples of an irrational number is the square root of 2, the square root of 19, and pi. Some non-examples are -5, which can be written as -5 over 1, 3/4, 2.6 repeating, and the square root of 64. We need to also learn how to estimate irrational numbers. Well, we do so by finding its place between perfect squares that we do know. 73 lies between the square root of 64 and the square root of 81. So what we have to do is we have to figure out which one is it closest to. Well, it's 9 away from 64, and it is 8 away from 81, so it's just over half. So since it's just over halfway between 8 and 9, it'll be 8.6. 13, the square root of 13 is between the square root of 9 and the square root of 16. It's 4 away from the square root of 9, 3 away from the square root of 16, so it's just over half. So it's just over halfway between 3 and 4, so it's about 3.6. The square root of 38 lies between 36, the square root of 36, and 49. It's 2 away from the square root of 36 and 11 away from the square root of 49. So it is a lot closer to square root of 36. It's a whole lot closer to 6 than it is to 7. So we could say this is about 6.2. And the square root of 97 is between the square root of 81 and 100. It's 16 away from the square root of 81, and it is 3 away from the square root of 100. So we're going to place it really, really close to there. And since it's really close to 10 and not 9, it's going to be about 9.8, maybe 9.9. The second section in our review is the Pythagorean theorem. Here we see an illustration of the Pythagorean theorem where it states that the sum of the squares of the two smaller sides is going to be equal to the square of the longest side, called the hypotenuse. Well, here we see that 3 squared plus 4 squared should equal 5 squared. 9 plus 16 does equal 25, so that is a proof. Now we're going to do 2 examples to solve Pythagorean theorem. Here we have a situation where we know the 2 legs and we do not know the hypotenuse. A, in this case, is 5, B is 12, and C is x. So what we do is we substitute those values in for our equation. 512 plus 12 squared, 5 squared plus 12 squared equals x squared. Well, 5 squared is 25, and so in this next step we evaluate. 12 squared is 144, and x squared is x squared. Now we add 25 plus 144 since they're on the same side, and we get 169. Now since we do not want to know what the area is on this side of the triangle, we want to know the length of x, we need to take the square root of both sides. The square root of x squared is x, and the square root of 169 is 13. Therefore, the length of this hypotenuse is 13. Our last example is one in which we know the hypotenuse, but we do not know the base, or the longer leg. A is 8, B is y, and C is 17. So we plug those values in. 8 squared plus y squared equals 17 squared. Then we evaluate what the values are between the exponents. 8 squared is 64, y squared is just y squared, and 17 times 17 is 289. Now in this case we notice that 64 is on the other side of the equal sign compared to 289. So in order to move it away from this side with the y and take it over to the other side, we're going to have to subtract it from both sides. When we subtract it from both sides, we see that y squared is 225. Now we need to find the length of this side, so we take the square root of both sides, and we see that y is 15.